I want to talk about the Terraquas that we built in the classroom, and this is a diagram of how to build a Terraqua. First we started with three 3-liter bottles. We cut the bottom so that this one would sit into the top. You can see this 3-liter bottle goes in, and then another 3-liter bottle goes over to the top so that we can fill the top with the materials we need and then enclose it. The important things of the Terraqua is first we put some carbon ammonia on the bottom of the Terraqua, and this is to deal with the smell that was caused from sitting there for 3 weeks. Then we have ponds here at our school, so I take pond scum out of the bottom. I put the pond scum in the bottom, and the reason we do that is it's critical that you take pond scum from a working pond that already has organisms in it, because that's where you get the bacteria that's going to make the nitrogen cycle in the bottom of the Terraqua go. Also, we had dragonfly larvae, excuse me, mosquito larvae. We put aquatic plants in there, tadpoles, snails, and 2 to 3, 4 fish in there. For 3 weeks, this was able to live with all of the things staying alive. And the reason that goes is because with the nitrogen cycle going in there, and then we also have an oxygen and a carbon dioxide cycle, and the water cycle, which I'll talk about in a little bit. To design the top, you end up with about 3 rocks to do the spout here. This stops the pea gravel from flowing down into the bottom and staying up here. Then you take soil compost. In the soil compost, we planted bean roots, or bean seeds. The reason you use bean seeds is because they are legumes and create nitrogen or fix nitrogen into the soil. So that does the nitrogen cycle on the top of the plant. Also, we planted grass seed on the top, which gives the oxygen carbon dioxide cycle. Plants growing that create that cycle keep it going. About 4 inches of pea gravel, about 4 inches of compost soil. The reason you use compost soil again is because you want that natural bacteria that is in the soil. In the top we had, some groups had snails, small lizards, or small toads in the top to live. And what happens in here, you cap it, so all this water that is in the bottom is all the water that is in there for the 3 weeks, similar to our environment on Earth. All the water on Earth is all the water that's ever been here and that will ever be here. So you have that same cycle in here. Let's slide over to talk about the water cycle. In the water cycle, what we have here is you have that water level down here. The roots from the bean plants and the grass seed come down, they suck up the water that's on the bottom, and then they transpire out their leaves, and we can actually see this happen in the window. Little droplets form. These droplets evaporate going up to the top of the bottle. Eventually they can condensate on the top of the bottle, and you can see the little droplets form on the top of the 2-liter bottle. It starts to run down. We call it precipitation, even though the majority of it actually runs down the side of the bottle, but a few drops do fall too. When it runs down, it comes back down to the soil here, and it percolates through the soil and through the pea gravel. As it percolates through the soil, it goes down and takes the nutrients from the soil, brings it back down to our aquarium part, and so some of the nutrients that we need in our aquarium part are actually coming from the soil up here. Then that water cycle starts over again, and you have the roots taking the water back up, transpiring, evaporating, condensating, precipitating, percolating, and over, and that's our natural water cycle inside of the Terraquas. Last, we move over to the nitrogen cycle in our Terraquas. And the neat thing about the nitrogen cycle in our Terraquas is there are 2 different nitrogen cycles happening in the Terraquas. The first nitrogen cycle is happening in the land part of the Terraqua. And with that, you have your plants, and they need nitrogen. And the nitrogen comes. So we have the plants, which are living organisms. Because it's not a very large area, the plants grow up and they do start to die because they can't come out of the top. So then you end up with plants needing nitrogen and living organisms and plants dying, decaying, creating waste in there, which brings nitrogen back to the soil. Remember I told you earlier we planted bean roots in here. The bean roots and the bacteria in that compost soil are what fix that nitrogen back into the soil. And then the plants are able to use that nitrogen again to grow, and that cycle goes over and over again. But we have another interesting nitrogen cycle in this because we have a nitrogen cycle in the bottom, which is in the water. The interesting part about that is, again, plants need nitrogen, which is the start of the nitrogen cycle. The fish in here, and the tadpoles and snails, they eat the plants. They create waste, and because it's a small environment, some of them eventually start to die. But they create waste, and we have Nitrosomonas bacteria in the bottom. Nitrosomonas convert that waste into nitrites. Nitrites are not a usable form of nitrogen for the animals in the bottom of the Terraquas, but the usable form is when you have Nitrobacter, which is another bacteria that came from that pond scum that turns the nitrites into nitrates. And nitrates are usable by plants. Plants are what the fish eat. Fish have waste. You got your Nitrosomonas, back to Nitrobacter, and then you have that nitrogen cycle happening in the bottom. And then the other cycle that I want to talk about real quick is obviously you have the carbon dioxide oxygen cycle going through all this Terraquas as it is a contained unit. We built these about 3 weeks ago, and if you look over here, these are about 3 weeks old, and we still have the fish living in the bottom. We still have the organisms living in the top. The water cycle is still going. I haven't opened them, and the plants are still growing. The water plants are still thriving, which is very unique because if you take a minnow and just put it into a jar, it won't last a day. But yet these minnows, and they're guppies from our pond, so they're not a very hardy fish, have lived in here for 3 weeks without me putting anything in there as far as food or anything else. I'm Mr. Johnston. Thank you for listening to our Terraquas project.